Hey, boys and girls, welcome to sixth grade Earth Science. And today's lesson, we are going to focus on the sun. The standard specifically states analyze and interpret data from the surface of the features of the sun, which include the photosphere, the corona, sunspots, prominences, and solar flares, to predict how these features may affect the Earth. To begin this lesson, I am going to share with you a video clip that it is my hope that it will pique your interest and your curiosity to learn more about the sun.
The sun has shed light on our home for over 4 billion years. It will continue to do so for another 4. It is massive, almost beyond comprehension. Constant, yet ever-changing. Born from a swirling cloud of dust and gas, it is a giant fusion engine that drives the solar system. It seethes and boils like a living thing. Loops of plasma rise up so large they would dwarf Earth. Explosions flash on its surface. And yet the sun also gives us warmth and life and beauty.
All right, I thought that was a great start to our lesson about the sun. Definitely piqued my curiosity. The sun's surface features are quite visible, but only with special equipment. For example, sunspots are only visible with special light filtering lenses. And looking at the sun is never a good idea to just look at it with your naked eyes. So you always need to make sure that you are using specialized equipment when you are investigating the sun. The sun's energy travels to Earth at the speed of light in the form of electromagnetic waves. The vast majority of these waves are invisible to us. They include the gamma rays, X-rays, and ultraviolet radiation, also known as UV rays. The most harmful of the UV rays are almost completely absorbed by Earth's atmosphere. Less harmful UV rays travel through the atmosphere and can cause a sunburn. The atmosphere layer that they are talking about here is our ozone. The sun's atmosphere consists of the photosphere, the chromosphere, and the corona. The inner layer of the sun's atmosphere is called the photosphere. Photo means light, so the photosphere is the sphere that gives off visible light. At the beginning and the end of solar eclipse, you can see a reddish glow around the photosphere. This glow comes from the middle layer of the sun's atmosphere, the chromosphere. Chromo means color, so the chromosphere is the color sphere. During a total solar eclipse, a fainter layer called the corona is visible. The corona sends out a stream of electrically charged particles called solar wind. Sunspots. The most noticeable feature of the sun are cooler, darker areas known as sunspots. Sunspots are located where loops of the sun's magnetic field break through the surface and disrupt the smooth transfer of heat from lower layers of the sun, making them cooler, darker, and marked by intense magnetic activity. Sunspots usually occur in pairs. When the loop of the sun's magnetic field breaks through the surface, a sunspot is created where the loop comes out and where it goes back in. Sunspots usually occur in 11-year cycles, increasing from a minimum number to a maximum number and then gradually decreasing to a minimum number again. If you look at this image on the left, you'll see the approximate size of the Earth in comparison to some sunspots. So it gives you an idea of just how large these sunspots, this particular feature of the sun is. A strong solar flare can turn into a coronal mass ejection. A solar flare or a coronal mass ejection releases streams of highly energetic particles that make up the solar wind. The solar wind can be dangerous to spacecrafts and astronauts because it sends out large amounts of radiation that can harm the human body. Solar flares have knocked out entire power grids, disturbed radio, satellite, and cell phone communications right here on Earth. So if you look at the images on the page, you'll see that they look like these massive explosions, and that's exactly what they are. But because they're releasing these highly energetic particles, they can directly impact our power grid, satellites, radio, cell phone communications, anything electromagnetic. Now, these solar prominences are actually what create the sunspots. It's the beginning and the ending of these loops. So a solar prominence is another highly visible feature on the sun or solar prominences. If plasma flows along the top of the sun's magnetic field from sunspot to sunspot, it forms a glowing arch that reaches thousands of kilometers into the sun's atmosphere. Prominences can last lengths of time ranging from a day to several months. Prominences are also visible during a total solar eclipse. In the image, you can see just how large a solar prominence can be because that is the planet Jupiter in proportion to a solar prominence and the size of Jupiter. And we know that Jupiter is the largest of our 8 planets in our solar system. So in summary, sunspots occur in pairs because each is one side of the loop of the sun's magnetic field that reaches the sun's surface. These spots are cooler and darker than the rest of the sun's surface, and they are marked by intense magnetic activity. I'm also going to add that we know the sun is rotating on an axis as well because scientists are able to see that these sunspots are moving in a rotation, so they're able to track it, and therefore we know that the sun is rotating. A solar prominence are the plasma loops that connect the sunspots, and solar flares and coronal mass ejections are eruptions of highly energetic particles that can erupt from the sun's surface and cause problems with power grids and communication right here on the Earth.